It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is...
The U.S. swiftly shut down the James Webb Telescope after it revealed what NASA had long been concealing about Mercury. Though small and close to our colossal sun, Mercury is anything but ordinary, dazzling scientists with unexpected treasures like diamonds scattered across its fiery terrain. Yet beyond this glittering surface lies an enormous and bizarre core, defying all previous scientific predictions and sparking questions about the untold stories these discoveries hold. While Mercury might appear to be just a tiny speck near the sun, beneath its scorching exterior hides a trove of phenomenal secrets. Recent probes have unearthed staggering finds, including diamonds spread across its surface and a core far larger and stranger than expected, raising the burning question of what sets Mercury apart from its planetary siblings. Mercury's exploration began with Mariner 10, the first spacecraft to visit, which sent back close-up images of cratered, rugged world with a surprisingly strong magnetic field and an oversized core. Decades later, the Messenger mission deepened our understanding, capturing 200,000 images and revealing previously unseen parts of the planet. Among Messenger's most fascinating discoveries were unexpectedly high levels of calcium and magnesium on Mercury's dark side, a magnetic field stronger in the north, and evidence of volcanic activity and past explosive eruptions, all challenging earlier beliefs about the planet's geological inactivity. In 2012, Messenger also found water ice hidden in permanently shadowed polar craters, suggesting that even on this blisteringly hot planet, conditions might exist to support basic life forms. This possibility sparked exciting new questions about life in extreme planetary environments. Looking ahead, the Bepi-Colombo spacecraft, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is set to arrive at Mercury in 2025 to gather even more detailed data about its surface and geological history. Despite Mercury's proximity to the Sun, it boasts a strong magnetic field and persistent water ice, adding to its list of astonishing features. Perhaps most mind-bending of all, Mercury's day is longer than its year. It takes just 88 Earth days to orbit the Sun, but 176 Earth days to rotate once on its axis. This creates strange effects, including a sun that appears to pause, move backward, and then continue across the sky, a result of Mercury's slow spin compared to its fast orbit, caused by tidal locking over billions of years. The Sun's gravity has gradually slowed Mercury's spin, and unlike the Moon, which is fully locked to Earth, Mercury is in a 3:2 spin orbit resonance, meaning it spins 3 times for every 2 orbits around the Sun. This unusual motion creates extreme conditions, with the sun-facing side baking in heat for months while the dark side freezes just as long, leading to some of the most dramatic temperature swings in the solar system. Mercury lacks a true atmosphere and instead has a thin exosphere, constantly leaking into space and replenished by solar wind, radioactive decay, and impacts from micrometeoroids. Recent studies, including 2020 Messenger data, revealed more water vapor in the exosphere than expected, likely formed when solar wind hydrogen reacts with surface oxygen. Despite its small size and slow rotation, Mercury has a significant magnetic field generated by movements in its liquid metallic core, a surprising find for scientists, though it's weaker than Earth's, offering partial protection from the Sun's fierce solar wind. Mercury's fast orbit and slow spin also create unique surface conditions, including hot poles, where the Sun appears to linger in the sky and permanently shadowed polar craters cold enough to preserve ice, raising the possibility that other materials, perhaps even organic compounds, may be hidden there. Studying Mercury is challenging due to its rapid orbit, requiring complex spacecraft navigation, like the Bepi-Colombo mission launched in 2018, which relies on 9 flybys before entering orbit in 2025. Mercury may have once spun faster, slowed over time by the Sun's gravity and past collisions, helping scientists understand not only its own evolution, but also planetary formation across the solar system. Researchers are particularly intrigued by the enormous core, which makes up about 85% of Mercury's volume, compared to Earth's 15%, leading to theories like the hit-and-run scenario, suggesting Mercury was once much larger but lost much of its outer layers in a massive collision early in the solar system's history. As new discoveries unfold, Mercury continues to challenge scientists' understanding of planetary evolution and remains one of the most fascinating bodies in our solar neighborhood. Dr. Eric Asphalt proposed that a giant collision early in the solar system's history may have stripped away Mercury's outer layers, leaving behind the dense, iron-rich core we see today. But Mercury's surprises don't end there. Despite its small size and slow rotation, it has a magnetic field, something scientists didn't expect, especially when compared to Venus and Mars, which lack global magnetic fields. NASA's Messenger mission revealed that Mercury's magnetic field is about 1% as strong as Earth's and, even more surprisingly, is offset by about 20% of the planet's radius, a shift that may be linked to crustal differences and how heat escapes from the core. In 2020, researchers found that Mercury's surface contains volatile elements like sulfur, potassium, and sodium, raising questions about how these materials, which usually evaporate at high temperatures, can exist so close to the sun. Dr. Patrick Peplowski suggests they may have been delivered by comets or asteroids long after Mercury's formation. One of the most exciting discoveries is the presence of water ice in permanently shadowed polar craters, kept frozen by the constant cold, along with potential organic material, dark patches that may contain complex carbon molecules, possibly offering clues to the origins of life. Mercury's geological activity has also surprised scientists. Once thought geologically dead, messenger data revealed features called hollows, small shiny vents hinting at recent volcanic activity, as highlighted by Dr. David Rothery. Adding to the intrigue is Mercury's chaotic terrain near the southern pole, a massive jumbled region the size of Texas, possibly shaped by quakes caused by the sun's gravitational pull as Mercury's orbit evolved, according to Dr. Thomas Waters. Recent research by Dr. Amir Khan suggests that Mercury has a liquid outer core and a solid inner core, but with a solid portion proportionally larger than Earth's, which may help explain its unusual magnetic properties. These discoveries challenge our understanding of how planets form and evolve, reminding us that even the smallest worlds close to home still hold vast mysteries. As future missions like Bepi Colombo continue to explore, scientists are eager to uncover what other secrets Mercury is hiding beneath its surface. NASA's Messenger mission confirmed details about Mercury's interior by studying its gravity, revealing that Mercury's solid center is about 1,260 miles, 2,000 kilometers, wide, making up half its core, compared to Earth's solid core, which accounts for only about 20% of its core volume. This difference plays an important role in generating Mercury's magnetic field, which, while weaker than Earth's, is surprisingly strong for such a small planet. Above Mercury's core lies a thin mantle, just about 260 miles, 420 kilometers thick, far thinner than Earth's mantle, which influences Mercury's heat distribution and geological activity. In 2012, Messenger discovered signs of ancient volcanic activity, including shallow depressions called hollows, formed as volatile materials evaporated from the surface. By 2020, scientists found evidence of a massive ancient magma reservoir beneath the planet, which likely shaped Mercury's surface and created the vast, smooth plain seen today, particularly in the northern hemisphere. But the surprises didn't stop there. In 2022, researchers detected nitrogen beneath Mercury's surface, possibly the remains of an ancient atmosphere forced underground by extreme heat and solar radiation, raising new questions about the planet's past conditions and its potential to have once supported life. Mercury's dark polar craters also hide water ice, some of it likely delivered by comets or asteroids in recent tens of millions of years, and dark patches thought to contain organic matter offer a unique chance to study the distribution of carbon molecules in the inner solar system. The planet's surface, though lacking plate tectonics, shows thrust faults formed as Mercury cooled and shrank, some reaching several kilometers high, and the discovery of young grobens suggests that Mercury may still be geologically active today. Its magnetic field, unlike Earth's, may be generated by liquid metal flow around a large, solid inner core, deepening scientists' curiosity about planetary magnetism. Beneath the surface, cracks and fissures may allow heat and possibly fluids to move between layers, and some researchers even speculate that hidden water reservoirs could exist deep underground, remnants of more temperate past or maintained by internal heat, similar to the oceans found beneath the icy crust of moons like Europa and Enceladus. Such possibilities raise exciting questions about Mercury's past environment and chemical processes essential for life. Studying Mercury's geology, volcanic history, and core composition not only helps explain its own evolution, but also enriches our understanding of how rocky planets like Earth formed and developed. Each discovery offers fresh insights into the early solar system, and future missions using advanced technology promise to reveal even more about this small yet mysterious planet. Ultimately, Mercury's study doesn't just unravel its own secrets. It helps illuminate the broader story of our solar system's formation and evolution, making a fascinating focus of planetary science and exploration.